Hello everyone, this is Mohana from Big Tech Multi-Tech of Rangaraju Dr. Shakuntala Engineering College, working as an assistant professor in the Department of Artificial Intelligence and Data Science. The subject name is Computer Graphics and Multimedia. Today we are going to discuss about the midpoint line drawing algorithm. What is line drawing algorithm? Line drawing algorithm. Line drawing algorithm is a set of instructions that approximates a line segment on discrete graphical medium like a printer or pixel-based display. How do line drawing algorithm work? Take the endpoints of a line segment as input. Calculate the slope of the line. Loop through the x coordinates of the line. Calculate the corresponding y coordinate. Plot the pixel at the calculated x, y coordinate. Repeat until the endpoint is reached. Types of line drawing algorithms. There are three types of line drawing algorithms. The first one is DDA line drawing algorithm. Second one is Bresenham line drawing algorithm. Then third one is midpoint line drawing algorithm. DDA line algorithm. DDA line algorithm. DDA, the full form is Digital Differential Analyzer, is a line drawing algorithm used in computer graphics to generate a line segment between two specified endpoints. It is simple and efficient algorithm that works by using the incremental difference between the coordinates and x and y coordinates of the two endpoints of plot the line. Advantages of DDA line drawing algorithm. The first one is that it is a simple and easy to implement algorithm. It avoids using multiple operations which have high time complexities. It is faster than direct use of the line equation because it does not use any floating point multiplication and it calculates the points on the line. Disadvantages for DDA line drawing algorithm. It deals with rounding of operation and floating point arithmetic, so it has high time complexity as it is orientation dependent. So it has poor endpoint accuracy. Due to the limited precision in the floating point representation, it produces a cumulative error. Then the Bresnan algorithm. The Bresnan line algorithm is used to scan converting a line. It was developed by Bresenham. It is an efficient method because it involves only integer in addition, subtraction, and multiplication operations. These operations can be performed very rapidly, so lines can be generated quickly. In this method, next pixel selected is that one who has the least distance from true line. It involves only integer arithmetics, so it is simple. It avoids the generation of duplicate points. It can be implemented using hardware because it does not use multiplication and division. It is faster as compared to DDA, Digital Differential Analyzer, because it does not involve floating point calculations like DDA algorithm. This is the advantages of Bresenham line algorithm. Disadvantages of Bresenham line algorithm. This algorithm is meant basic line drawing algorithm. Only initializing is not a part of Bresenham line algorithm. So to draw smooth lines, you should want to look into a different algorithm. Midpoint line algorithm. In computer graphics, the midpoint line algorithm is a technique used to render straight lines on raster display by calculating the midpoint potential pixels at each step and deciding which pixel to plot based on whether the midpoint lies above or below desired line, resulting in an efficient, visually accurate line representation. Midpoint line drawing algorithm attempts to generate the points between the starting and the ending coordinate. Midpoint line drawing algorithm procedure. Given data, starting coordinates x0, y0 and ending coordinates x and yn. Step 1. Calculate del x and del y from the given input. These parameters are calculated as del x is equal to xn minus x0, then del y is equal to yn minus y0. Step 2. Calculate the value of initial decision parameter and del d. These parameters are calculated as d initial is equal to 2 del y minus del x. Del d is equal to 2 of del y minus del x. Step 3. The decision whether to increment x or y coordinate depends upon the flowing values of d initial. Follow the below two cases. There are two cases in the decision parameter. Case 1, if d initial is less than or 0 means xk plus 1 is equal to xk plus 1, then yk plus 1 is equal to yk, d new is equal to d initial plus 2 del y. Case 2, d initial is greater than or is equal to 0 means yk plus 1 is equal to yk plus 1, then xk plus 1 is equal to xk plus 1, d new is equal to d initial plus del d. Step 4. Keep repeating step 3 until the endpoint is reached. For each d new value, follow the above cases to find the next coordinates. Now we are going to solve the problem. The question is calculate the points between the starting coordinates 20, 10 and ending coordinates 30, 18. Solution, the given data. The given data is starting coordinates and ending coordinates. Starting coordinates are represented as x0, y0. x0 is equal to 20, then y0 is equal to 10. The ending coordinates. Ending coordinates are representing as xn, yn. So xn is equal to 30, then yn is equal to 18. Step 1. Calculate del x and del y from the given input. The del x is equal to xn minus x0, then del y is equal to yn minus y0. xn is equal to 30 minus x0 is equal to 20. So 30 minus 20 is equal to 10. Then del y is equal to yn minus y0. Yn is equal to 18 and y0 is equal to 10. So 18 minus 10 is equal to 8. Step 2. Calculate the d initial and del d as d initial is equal to 2 del y minus del x is equal to 2 into del y value is 8. Then 2 into 8 minus del x value is 10. So 2 into 8, 16. 16 minus 10 is equal to 6. Del d is equal to 2 of del y minus del x is equal to 2 of 8. 2, then del y is equal to 8, then del x is equal to 10. So 2 of 8 minus 10 is equal to minus 4. Step 3. As d initial is greater than or is equal to 0 means case 2 is satisfied. So we have to calculate the xk plus 1 is equal to xk plus 1, yk plus 1 is equal to yk plus 1, d new is equal to d initial plus dd. If it is d initial is less than or 0 means we have to calculate the xk plus 1 is equal to xk plus 1, yk plus 1 is equal to yk, then d new is equal to d initial plus 2 del y. Now, the d initial value is greater than 0. So we have to calculate the xk plus 1 is equal to xk plus 1. Xk value is 20, then plus 1 is equal to 21. Yk plus 1, yk value is 10, plus 1 is equal to 11. D new is equal to D initial plus del D. D initial value is 6 plus del D value is minus 4. So 6 minus 4 is equal to 2. Similarly, step 3 is executed until the endpoint is reached. Next, we are going to find out the D initial value, D new value, xk plus 1 value, yk plus 1 value. The starting coordinates are 20, 10. So we have to mention xk plus 1 is equal to 20, yk plus 1 is equal to 10. The initial value is 6 means D new value is 2. Then xk plus 1 is applied for case 2. The initial value means 6 means case 2 apply, then we got the value of 21. Then yk plus 1 is equal to 11. The initial value is 2 means the new value is minus 2 means the initial value is plus 2. Plus 2 means here case 2 is applied. So case 2 applied means xk plus 1 is equal to 22, yk plus 1 is equal to 12. Then the initial value is minus 2, the new value is 14. Here the initial value is minus 2 means xk plus 1 is equal to 23. Then yk plus 1 is equal to 12. Then the initial is equal to 40. The new is equal to 10. If the initial is greater than or equal to 0 means we have to apply the case 2. Xk plus 1 is equal to 24. Then yk plus 1 is equal to 13. The initial is 10. Then the new is 6. If the initial is greater than or is equal to 0 means we have to apply the case 2. Then we got the value of xk plus 1 is equal to 25. Then yk plus 1 is equal to 14. Then d new value is 6 and then d new value is 2. If the d initial value is greater than or is equal to 0 means we apply the case 2. Then xk plus 1 is equal to 26. Yk plus 1 is equal to 16. D initial is equal to minus 2. Then d new is equal to 14. D initial minus 2 means it is here it is applied case 1. Then we got the xk plus value is 28. Then yk plus 1 value is 16. Then d initial value is 14. Then d new is equal to 10. Xk plus 1. Then here we apply the case 2. Then xk plus 1 is equal to 29. Then yk plus 1 is equal to 17. D initial is equal to 10 means we apply case 2. Then we got the value of xk plus 1 is 30. Then yk plus 1 is equal to 80. Now we are going to draw the graph x-axis and y-axis. X-axis is 5, 10, 15, 20, 25, 30, then 35. Then x y-axis is 2, 4, 6, 8, 10, 12, 14, 16, 18 up to 20. Then we plot the points. First is 20, 10, 21, 11, 22, 12, 23, 12, 24, 13, 25, 14, 26, 15, 27, 16, 28, 16, 29, 17, then 30, 18. Finally, we got the midpoint line drawing algorithm. Advantages of midpoint line drawing algorithm. Accuracy of finding points is a key feature of this algorithm. Then it is simple to implement. it uses basic arithmetic operations. Then it takes less time for computation. The result like a smooth as compared to other line drawing algorithm. The disadvantages of midpoint line drawing algorithm is this algorithm may not be an ideal choice for complex graphics and images. In terms of accuracy of finding points, improvement is still needed. There, there is no any remarkable improvement made by this algorithm. Midpoint circle algorithm. The midpoint circle drawing algorithm is an algorithm used to determine the points needed for rasterizing a circle. We use the midpoint algorithm to calculate all the perimeter points of the circle in the first octant and then print them along with their mirrors points in the other octants. This will work because a circle is symmetric about its center. The algorithm is very simple, similar to the midpoint line algorithm. Here, only the boundary condition is different. The octant, overall 8 octant is there, 4 quadrant and 8 octant. The first one is x comma y 45 degree, then y comma x. It mirror reflection is y comma x. Then second quadrant is x comma minus y. The mirror reflection is y comma minus x. The third quadrant is minus x comma minus y. The mirror reflection is minus y comma minus x. The fourth quadrant is minus x comma plus y. The mirror reflection is minus y comma x. Overall 8 octant in the x and y axis. X axis minus x axis plus y axis minus y axis. Then advantages of midpoint circle algorithm. It helps in scan conversion algorithms very efficiently by drawing the curves geometric on display of raster. The non-parameter equations are easily transformed by this method using a function f of xy is equal to 0 in order to describe the curve, to draw a curve and convert it to algorithms. Disadvantages of circle algorithm. It consumes too much of time. The distance between the pixel is not equal, so we won't get smooth circle. SDG goals, Sustainable Development Goals. The first one is no poverty. Second, zero hunger. Third one is good health and well-being. Fourth one, quality education. Fifth one, gender equality. Then sixth one, clean water and sanitation. Then seventh one, affordable and clean energy. Eighth one, decent work and economic growth. Ninth one, industry innovation and infrastructure. Tenth one, reduced inequalities. Then 11th one, sustainable cities and communities. 12th one, responsible consumption and production. 13th one, climate action. 14th, life below water. 15th, life on land. 16th, peace, justice, and strong institution. 17th, partnerships for the goals. Our topic is line drawing algorithm. So, sustainable development goal is matched for fourth one. Fourth one is quality education, enhancing computer graphics education by teaching efficient line drawing algorithms, DDA line algorithm, Bresnan's algorithms, and midpoint line algorithm, developing educational tools and software that use line algorithms for learning geometry and visualization. Second, SDG 9. SDG 9 is industry, innovation, and infrastructure, improving computer-aided design (CAD) tools with optimized line drawing algorithms for infrastructure and industrial applications, supporting the development of efficient graphics processing in gaming, simulations, and engineering. SDG 11 Sustainable Development Goal 11 Sustainable Cities and Communities, utilizing efficient line drawing in urban planning and GIS geographic information systems for smart city designs, assisting in mapping and visualization for sustainable infrastructure projects. SDG 12 Responsible Consumption and Production, optimizing algorithms to reduce computational power consumption, making digital processes more energy efficient, encouraging sustainable software development practices with minimal resource wastage. SDG 13 Climate Action, applying the line drawing algorithms in environment monitoring and visualization tools for climate data analysis, enhancing simulations related to climate mode management through the efficient rendering technique.